Good day, welcome to another YouTube tutorial by Mauda Prof. So now today we're going to solve Bernoulli equations. These are equations that can be reduced to linear first order linear equations. So for you to be able to solve this, you should have watched my previous video. If you didn't watch it, please go and visit that video before you watch this one. So we solve the Bernoulli equation if it is in this format. If the ordinary differential equation is in this format, that's when we can use the Bernoulli. Where n should not be equal to 0. If n is equal to 1, this is going to be a simple linear equation. So if y is any number different from this, that's where in we use the Bernoulli equation. Let me take an example to demonstrate this method. Say we're given the following example. So we can see that this equation is in this format. So we're going to identify. So here in this method, in order for us to solve it, we let v to be y minus n. We're going to identify our n. Our n there, it's what? It's 3. N is equal to 3. So v equals to y to the power 1 minus 3, y to the power negative 2. So if we divide throughout by, from there we divide throughout by this, whatever the y variable that we've got on the right hand side, we divide by it throughout. So 1 over y cubed dy over dx minus 5y over y cubed equals to minus 5 over 2x. So these two will cancel each other. Y cubed over y cubed. Let me just write it for now. So from there, what we're going to do is we're going to write this as y negative 3 dy over dx minus 5 y negative 2 minus 5 over 2x. Let's put it like paper like that. So from there, we are going to replace. So after finding v, you should differentiate this v in terms of x. dv over dx is going to be negative 2 y minus 1 minus 3 dy over dx. Remember, y it's also in terms of, it's a function of x. So divide by negative 2, it's negative half dv over dx. It's y negative half dy over dx. So I've done that before I came to this equation, but it's okay. So if you look at this, this is similar to what we have right here. And this is similar to this. That is the reason why we let v to be 1 minus n. That is why we choose this. That's the reason of choosing that. Let's replace negative 1 over 2. Let's substitute negative 1 dv over the x minus 5. So y to the power negative 2 is equal to v minus 5 over 2x. So from there, if you look at this equation it's an first order linear differential equation. You can solve it using the method that we learned in the previous video. So now the first thing that we're going to do is to standardize it by multiplying by negative 2 dv over dx plus 10 v 5x. So let's find the integrating factor. Our integrating factor is going to be e to the power 10 dx, which is e to the power 10x. So multiply by e to the power 10x throughout. E to the power 10x dv over dx plus 10v e to the power 10x equals to 5x e to the power 10x. Let's continue with the example. Let me just put this here. E to the power 10x dv over dx plus 10v e to the power 10x equals to 5x e to the power 10x. So this is dv over dx e to the power 10x equals to 5x e to the power 10x dv e to the power 10x 5x e to the power 10x dx. Sorry for that. From there, introduce the integral sign both sides. These two will cancel each other, so we'll be left with v e to the power 10x. Can take out 5 and set the integral sign x e to the power 10x dx. So in order for you to integrate this, we use integration by parts. U dv equals to uv minus v du. If you did cram pass and forget, you're in trouble. Go and revise your first year notes. Let u equals to x dv equals to e to the power 10x du equals to dx. V is equals to, it's the integral of this, which is just 1 over 10 e to the power 10x. So let's find e to the power 10x 5. We're trying to integrate this. So uv is x over 10 e to the power 10x minus v du, which is 1 over 10 e to the power 10x dx. So that's just 5x over 10 e to the power 10x. So this is going 1 over 10 times 1 over 10 again e to the power 10x plus v e to the power 10x. Oh, sorry, you couldn't see. V e to the power 10x equals to 5x over 10 e to the power 10x minus 1 over 100 e to the power 10x plus c v e to the power 10x equals to, now this is 1 over 2 x e to the power 10x minus 5 over 100, 1 over 20 e to the power 10x plus c divided by e to the power 10x e to the power 10x e to the power 10x e to the power 10x. So your v is equals to half x minus 1 over 20 plus c e to the power negative 10x. Our v, remember, in the beginning was equal to negative 2, so 1 over y squared is equals to half x minus 1 over 20 c e to the power negative 10x. Thank you for watching my video. Don't forget to subscribe, share, and press the like button below. Thank you very much.